For those of you just joining us, we are doing the warm-up problem on the board. So Usain Bolt has a 100-meter world record of 9.58 seconds. He is initially at rest when the starting gun goes off, and then I want you to find his acceleration and his final velocity. And when you're ready, put your answers in the Zoom chat. So there are a couple ways of doing this problem. We got a couple answers so far. We got Austin and Charles. Gonna get a few more answers. There definitely are a couple of ways of doing this. So I will show both ways when everyone is sort of ready to see how we do this. There are a couple of ways of doing this, so I'm just gonna give you all a chance to finish working on it. So I thought this problem would be more challenging, but it looks like you guys are getting the hang of it. So clearly I have misjudged your abilities. So let's take a few more minutes to see if you can figure this out, and then I will show you how I could have done it. There are definitely multiple ways of doing this. By multiple, I think I mean two, and then I'll show you both ways. Let's take another minute or two to see where we are. There's just like this massive glare on the board. No, that's better. Okay, so I'm going to show you how I did it. And remember, there are a couple of ways of doing this, and I'm going to show you both ways. So this is the way I actually thought of it. I thought of it as, okay, let's try to figure out his average velocity. Because we know how fast he starts off with. We don't know how fast he finishes off with, but we sort of know how fast he went on average, right? So how I thought of it was, okay, we know that if we start with, let's first going to do is we're going to start with this equation. X of t is x naught plus 1/2 v naught plus vf times t. So the way I thought of this was, okay, we can figure out his average velocity, and if we just take his distance traveled and divide it by his average velocity, we can figure out and plug in our time. We can figure out what our final velocity is, right? Because we can determine what our average velocity is. So we know that he starts off an initial displacement of 0. We can assume that. So we know that his final displacement, 100, is 1/2 times v naught. So v naught is 0 plus vf times t. Now t is 9.58 seconds. So when we multiply this out, we get 200 divided by 9.58 is vf. So vf should be 20.88. So what I did here was, we know how far he traveled, we know the time he took. So from that, we can figure out his average velocity. And his average velocity is just his beginning velocity and his final velocity and divided by 2. And so we got his final velocity was 20.88 seconds. So to figure out his acceleration, for this method, what I'm going to use that his final velocity, v squared, is his initial velocity, v squared, plus 2a delta x. His final velocity squared is 20.88 squared. His initial velocity is 0 plus, so this is going to be 2a times 200. And so you'll get that his acceleration is 2.18. So this is the way I thought of it. There's another way of doing it, which is probably the more straightforward way. And I'm going to show you right now. So this is where we start off just the regular displacement function. X of t is x naught plus v naught times t plus 1/2 a times t squared. Oh, I'm going to make this one. This should be a t right here, so you can see it. Okay, so his initial velocity is 0. His initial displacement is 0. So 100 is 1/2 times a times t squared is 9.58 squared. And so then we'll get that this is 200. We'll get that is what? Acceleration is 2.18. This is probably the most straightforward way. And to figure out his velocity, we can just simply do v of t equal to v naught plus a times t. His initial velocity is 0, so his v of t is 2.18 times 9.58. And so his final velocity should be 20.88 meters per second. Is that what people got? Does that make sense for most people? Yes, no, maybe so.
Yes.
Yes, okay, cool. Okay, before we move on, I just wanted to see if anyone had any questions about stuff on the asteroid mission. Is there any problem that you wanted me to go over? I had a video of me doing some problems from previous classes live stream. So hopefully you were able to see some of the answers from our classes live stream. But because it was sort of off the top of my head, I wasn't super organized about it. So I definitely messed some things up. Is there any problem that you wanted me to go over in the asteroid mission?
I couldn't find our class's live stream.
Should have been posted on YouTube. Okay, let me see if
I only saw period 2s, but maybe my computer was off.
It should have been first period 928. Oh, is that the issue? No, no, no. It should have been first period 928. Yeah, it's on my, here, it was this link right here.
Oh, never mind. I just didn't see it. Never mind.
Okay, cool. Okay, so does anyone have any questions about the asteroid mission? Are we okay with that? Do you feel like we're comfortable with it? Yes, Mr. Hu, we're super comfortable with it. Oh, great, that's awesome. Okay, so here's what we're gonna do today. What we're gonna do today is we are going to move on to a new project. So here's what the project entails. What we're going to do is we are going to do we're going to do some designing of cars. More specifically, I've titled this project Mario Cars. So here's what's going to happen. Okay, so here's what's going to happen. So your goal here is you're going to design this ultimate Mario car with the goal of being the fastest racer in all Whoville. So this project is going to be a little bit different than the last one. This one's going to be a group project with some individual sections for assessment. So basically, it's going to happen. You're going to work on the design together. You're going to work on a lot of things together. But there's going to be a little individual sections where it's so that way I can assess you. And then so for this project, I want you to switch groups from the one you are in. Hopefully, you had a chance to make some friends and stuff. So to give you a chance to meet some new people, I want you to switch groups. I'm going to let you pick your groups. I don't really care. Just pick a new group with groups of 3 or 4. If you have some people who you were in the group with last time, that's fine. But let's just try to keep it to that. Most people, you're meeting a bunch of new people. And I'm not going to really like babysit groups here. You can switch groups in a second. I just want to give you a chance to, I just want to sort of just talk about what we're going to do. So to start off with, I want you to, draw your ultimate racing car. You can figure out how you want to do that. Some people are really good at doing it on the computer. Some people are really good at drawing by hand. You can work together to do this. I don't really care how you do it. I just want you to draw visually. You will not be, unlike last time, you won't really be penalized for having a really cool design. In fact, your design, it won't really have a play in the rest of the things. So I just want you to be really creative with your design. You can be really cool with it. Yeah, so spend some time making a really cool design. Afterwards, what's going to happen is that you're going to customize your car with a bunch of various components, similar to like Mario Karts. If you ever play Mario Karts, if you know, in that you can pick a lot of different stuff. You can pick like, what kind of parachute you want. You can pick like what kind of car you want. You can pick what kind of tires you want. And this is going to be the same thing. You're going to be able to pick a bunch of different things, and each different thing is going to have a different statistic. So in our project here, what I have here is I've written down 5 different statistics that you're probably going to have in this class. We're going to be using acceleration, we're going to be using velocity, we're going to use braking, we're going to use handling, and we're going to use sort of bad weather / courses. So I'm going to go over these in a second. Just as I just want to give you a glimpse of how each statistic does. Say each one of the components is going to have covered one of these different things. So there are 4 sets of components you can customize. You can pick your tires. There are 5 different tires for you to pick from. You can pick 5 different types of engines. You can pick 5 different types of car chassis, car types. You can pick 5 different drivetrains. So this is, and I'll talk a little bit about it right now. So there are 5 kinds of tires you can pick. There is your standard. These are your standard road tires that come with your car, very standard, so they're sort of good all around. You have your super soft tires. So these are the tires that Formula 1 cars use. So they're very, very, very fast. Unfortunately, they are very bad in any sort of like outside of like really perfect conditions.
I think track.
Your off-road. Sorry.
They have bad traction. They like drift.
Yeah, so there's a lot of negatives with them. Yeah, they drift. So they're really good on perfect conditions. They're not so good in other conditions. You have off-road tires, which are sort of the opposite. They're really good in crappy conditions, and they're not so good in good conditions. You have aluminum wheels. These are the wheels that are used on jet cars with jet engines. So these are insanely fast, but they're even worse than super soft tires on different conditions. And then last but not least, you have treads, sort of like a tank. These are really good. These are just stunning in practical conditions, and they're not so good on regular roads. So those are sort of the 5 wheels you can choose from, and each one of these has a different level of statistic. So you have some of these that have really good velocity and really good acceleration, and then with really bad handling for bad weather. They should hopefully be balanced so that the total numbers are the same. But yeah. Then you have 5 different engines. So to choose from, you have a standard V6 engine, which comes in a Tesla, not a Tesla, a Formula One car. You have the Thrust SSC. This is a jet engine that is used on the fastest land vehicle of all time. It can travel up to 770 miles per hour. So because of this, you have really insane top speed. You have really insane acceleration. And because it is a jet engine, you have horrible handling. You can't really do corners and stuff well. Then you have a Tesla, which a Tesla, you just have really good velocity, because it's an electric car. So in an electric car, your torque is instant. So you have really insane acceleration. You have really good velocity here, and then your handling is not so good. You have a V8 engine. This is what goes in the Bugatti. So it is really fast, and it's not bad in acceleration handling. And then last but not least, you have a V4 engine. So these go in like rally cars, and these are the kind of cars that you see that do a lot of drifting, that do a lot of off-roading. So they're very good in tough conditions. That's why it's really good handling. So your car chassis, so this is just sort of the main body of your car. When you're drawing your car, you don't actually have to make your car look like this. It's just, these are just sort of the statistical things that your car will have. You can make your car look completely different than this, or you can make your car look like this. It's up to you. There are 5 different chassis I'm going to introduce to you. We have the Toyota AE86. If any of you watch Initial D, this is the tofu shop car, and it's very good. It's a classic car. It's a Toyota. Everyone always underestimates it, and it's really, really, really good handling. Unfortunately, because it's a Toyota, a regular stock Toyota Corolla, it's not very good in the velocity and acceleration department, but it's good in everything else. Then you have a Lambo, which is just a fast car. You have a muscle car, which is got a lot of power to it. You've got an F1 car, which is also very fast. And then you have a Cybertruck, which is fun. Who doesn't love Cybertrucks? I had to throw that in there. Who doesn't love a good Cybertruck? Okay, so this is probably the most confusing part, the engine drivetrain. So each one of these is sort of where the engine is, what kind of drive your car has, and what kind of where the engine is placed. So you don't really need to know exactly like what the details of these are. So I'm just going to say it out loud just so you can sort of get an idea that I'm not making all this up. So an FF means front wheel drive, front engine. No, yeah, front wheel drive, front engine. So which means that your cars accelerate from the front. Those are what's driving your motor, and then your engine is also placed in the front. And then you have an FR, which is a front engine rear wheel drive. Then you have an MR, which is a mid-engine. Your engine is placed in the middle, but your rear wheels are what's accelerating your car. You have an RR, which is a rear engine rear wheel drive. And then you have a 4-wheel drive, which is just all 4 of the wheels can generate power. To sort of explain a little bit more, an FF, these are sort of your standard cars. So the car that you buy from your, to go commute to school or commute to work, or your parents probably have, this is probably an FF. An FR, these are sort of more of like your little, like your Toyota, like sort of like your drifting cars a little bit. So you don't see these a lot, but these are there. Your MR, so these are like your super powerful cars. So like your Bugattis have MRs. Your engines are placed in the middle. So any like sort of very fast car is usually an MR, and that's why they only have 2 seats. And then you have an RR, which is your rear wheel drive, rear engine placement. And these are pretty much used exclusively for like Porsches. So yeah. Okay, so what you're gonna do is you're gonna pick one of each column. So maybe you're gonna pick this aluminum wheels with like a jet engine because you want yours to be really fast. And so what's gonna happen is because each one of these have a different statistic, you're gonna add them all up at the very end. So there's a table here where you're going to add up so you're gonna, in this table here, you're just gonna copy and paste the components you chose. We're gonna just write it in. And then what you're gonna do is you're gonna sum up your statistics for each value. So maybe you have 40 points in acceleration, maybe you have like 20 points in velocity, maybe you have like 10 points in handling or something, right? It's up to you what you chose. And then afterwards, you're going to fill in the bottom value with your statistical values for your acceleration. So the way I've written this out is that each car has a base value for certain things, and then each point adjusts that value by a little bit. So actually, I have an updated document here. Okay, so in here, what I have is that for acceleration is how fast your car can get up to its maximum velocity. So the base acceleration for our cars is 5 meters per second squared, which means that every second your car speeds up by 5 meters per second. And each point you have in acceleration adds 1 meter per second squared to the acceleration of your car. Velocity is just how fast your top velocity is. So all cars have a base fastest velocity of 40 meters per second, with each point adding 4 meters per second to the top velocity of your car. Braking is just how fast you can decelerate. You can think of this as the opposite of acceleration. Each car has a base braking of -5 meters per second squared, which every point increasing your braking by -1 meter per second squared. So handling, this is going to be one of the more challenging ones. Handling is just how fast can you go around turns. So what we're gonna do is we're gonna analyze a bunch of race courses, and each race course is going to have a different maximum safe speed for each particular turn. So the main thing is that your maximum speed around a turn cannot exceed the top speed of your car itself. This just in case your car. And each point that you have in handling adds 4 meters per second to the maximum safe speed at each turn. So if the safe speed of the turn is 10 meters per second and you have 1 point in handling, that means your car can go up to 14 meters per second on that turn. And then negative points subtract 4 meters per second from maximum safe speed. And then bad weather. This is how well your car can handle sort of really rough conditions. So what's going to happen is that in certain courses, cars can be penalized because of rain or something. And then bad weather is just how much reduction of the penalty your car can have. We'll talk about this a little later on. Just for now, just know that each point is a 3% reduction to the penalty of bad weather and up to a 90% reduction if your car has 30 points in bad weather. And then negative points just do the opposite. If you have -15 in bad weather, it's going to increase the penalty by 45%. Okay, so once you sort of pick your components, you sort of figure out how many points you have in each particular statistic, what your overall acceleration is or velocity is. Then I want you to, as a group, I want you to explain your car design. I want you to explain which components you picked and why. I want you to think about what you're considering the aesthetics, the performance, speed, acceleration, whatever. And then I want you to talk about what statistics you decided to emphasize and which ones you didn't care about. Okay, so this was kind of a mouthful. Does anyone have any questions about how to start?
So the safety of your car matters.
Not really. It's
Like
more.
If you wanted, could you just make it as fast as possible and just?
Yeah, you can make it insanely fast. The main thing about that is that it's not that the safety is an issue. It's just that your car won't be able to take a turn as fast. So which means that your car is going to have to brake in order to go through the turn. So you don't have to worry about necessarily your car crashing. We're just going to assume that your car is going to go through it safely. But in order to go through it safely, you have to decelerate. So there is a chance that your car may never even get up to its top speed, depending on how you built your car. So you're not going to worry about your car crashing or not, but you will have to consider can your car even get up to its maximum speed?
You can't do zero handling. You have to do at least like some sort of balancing
Yeah, so I mean, so here's the thing. You theoretically could have zero handling. The issue is that, because of that, you won't be able to go through turns fast at all, which means that your car will have to slow down a lot in order to go through the turn. So that's the issue. So it's up to you how you want to prioritize things. Because this is you can think of it as a beta build of a game, so I haven't really balanced it out yet. So you're going to be the test trial here. But I'm going to let you decide what you want to do for it. Anyone have any other questions? Okay, so
open the document.
There's one on Canvas. Is it not openable on Canvas?
Mario Kart Part 1 design. Yeah, it says I need access.
Yeah, it says we have to request access.
That's fine. Should have been. Oh, yeah, hold on. It's because it was initially set to Sequoia only. Okay, cool. You should be able to see it now. Yes, you can see it? Yes, okay, okay, cool, perfect. Okay, so if you don't have any questions, I'm gonna let you get started. So you're gonna pick new groups. It can be some same people, but just for the most part, try to meet some new people, and then I will let you do it however you want.
Oh, also, how big do you want groups again?
Sorry?
How many people per group do you?
3 to 4. Definitely no bigger. If you have to do smaller, that's fine. But definitely 3 to 4. Oh, you've
Mr. Hu, isn't class over?
Okay, so we have a minute left in class, so I'm just gonna quickly wrap up. So your only homework is to try to finish. I think most people have gotten pretty close to finishing this. So your only homework is to try to finish this. Hopefully you can, hopefully you're at least done with most of the numbers part. Hopefully that wasn't too hard. If you have any questions, please let me know. And then in terms of submitting it, you can just each person. I do want each person to submit it, but you can submit the same Google Doc. And I think it is important. I also want to make sure that each design, each submission, you have your picture of your car. So a lot of people have their car, they don't have a picture yet. I do want to see a picture. I do want you to draw it out because I want to see your creativity and I want to see some cool cars. And I don't just want to see a bunch of numbers. So so that's that. And that's your only homework for the weekend. Hopefully that's not too much. Does anyone have any questions about that? Okay, otherwise you're free to go. Have a nice one and I'll see you all on Monday.
Thank you.
Thank
Bye-bye.
you.
Bye, Mr. Hu.
Thank you, Mr. Hu.
Adios.
Bye.
Thank you.
Thank you, Mr. Hu.